Let's do some monitoring progress questions from 8.3 together just so we can see how I would do my work with you. So first we're going to use example 1 where we're finding the axis of symmetry and the vertex. I'm going to do monitoring progress numbers 1 and 3. And I already wrote them down here on my piece of paper. So let's get to work. So first for part A, we're going to find the axis of symmetry. Remember, we're going to use the formula for the axis of symmetry. X equals the opposite of B over 2A. Now, from my equation, I know that I'm using standard form. Standard form is ax squared plus bx plus c. In this equation, our a is going to be the 3, the number in front of the x squared term, and our b is going to be this -2, the number in front of the x term. In this equation, this actually doesn't have a c, so technically the c would be 0, but we don't need this c for right now. Let's plug these numbers into our formula. So we're going to have the opposite of b. It's going to be the opposite of -2 over 2 times our a, which is 3. Let's simplify here. Negative, or the opposite of -2 is +2 over 2 times 3, which is 6. And now I'm going to simplify this and I get x equals 1 over 3. That is our axis of symmetry for this equation. Let's go on to part B. For part B, I'm going to take this 1/3 and plug it into our equation up here and find out what it equals. So I'm going to replace it on the left side. We're going to evaluate and find f of 1/3 equals 3 times 1/3 squared minus 2 times 1/3. Let's simplify. We're going to have 1/3 squared, which becomes 1 over 9. And then we'll keep the rest of it the same here. Let's simplify this. This is going to become 3 over 9 minus 2 over 3. 3 over 9 can be simplified to be 1 over 3 minus 2 over 3 is going to equal -1 over 3. Now let's put it together. Therefore, our vertex is going to be the ordered pair 1 over 3, comma, -1 over 3. And there's our vertex. Let's do the same thing for monitoring progress 3. I already wrote down the equation from the book here. Here's our equation. We're going to start off the same way. Let's start with finding the axis of symmetry, the opposite of b over 2a. Let's label our numbers from our equation. Our a is -1/2, our b is 7, and our c is -4. We're going to plug these numbers into our equation. So we have the opposite of 7 over 2 times our a is -1/2. This becomes -7 over -1. And let's divide these two here. We get x equals 7. Now I can take this x equals 7 and I can plug it into our equation and find the y of the vertex. Let's plug 7 into the original equation. So we're going to have h of 7 equals -1/2 times 7 squared plus 7 times 7 minus 4. We're going to simplify. Let's do order of operations. 7 squared first. -1/2 times 49 plus 7 times 7 minus 4. Now let's multiply. -1/2 times 49. Well, that's going to be 24.5. Sorry, -24.5. Plus 7 times 7 is 49. And then minus 4. Let's put this together. This is going to be positive 24.5 minus 4 is going to be 20.5. Therefore, our vertex is going to be the ordered pair 7, comma, 20.5. Now let's check our work in our calculator. Let's make sure that I plugged this in correctly here. So in my calculator, I'm just going to plug it in exactly how it appears in this original. So -1/2 times 49 plus 49 minus 4. Yep, and I got 20.5. So I know I got that correct. All right, so that is monitoring progress 1 and 3. That goes with example 1. We're also going to look at example 2 and do some monitoring progress questions from here. And this is when we're going to graph our equation in standard form. So we're actually going to start off the same way by finding the axis of symmetry and the vertex. Those are the first two steps. We're also going to find the y-intercept, which is just the c of the equation. So let me show my work here on my piece of paper. So I'm going to write down, we're going to do number 4. Number 4 from the textbook is h of x equals 2x squared plus 4x plus 1. Let's find the axis of symmetry. We're going to do x equals the opposite of b over 2a. So my b in this equation and my a, b, and c. My a is 2, my b is 4, my c is 1. We're going to do opposite of b over 2a. The opposite of 4 over 2 times 2, negative 4 over 4 equals negative 1. That's our axis of symmetry. Let's now take negative 1 and plug it into here, and we'll find the y of the vertex. So we're going to have 2 times negative 1 squared plus 4 times negative 1 plus 1. We're going to simplify negative 1 squared is 1 times 2 is 2. 4 times negative 1 is negative 4, and then plus 1. 2 minus 4 is negative 2, plus 1 is negative 1. Therefore, our vertex is the point negative 1, negative 1. Next up, I'm going to say the y-intercept. Our y-intercept is just the c of this equation. The c of our equation that we already said from above here is 1. So our y-intercept is 1. Okay, then I can go and make my graph of this parabola. So let me get my graph paper here. So I already wrote the equation, and I'm going to draw my coordinate plane right on here. Okay, our first step is we're going to draw in the axis of symmetry, and that is that negative 1 that I found first. This x equals negative 1. So I'm going to go and draw it with a different color just so you can see it and it stands out a bit. I'm going to go over here to negative 1 on my x-axis, and I'm going to draw a vertical dotted line going right through negative 1. There is my axis of symmetry. Now let's start to plot the points. Our vertex is negative 1, negative 1, so that point goes right here. Next up, our y-intercept is the point 1 on the y-axis. So on the y-axis, here's my y-intercept at 1. And now I'm going to draw its symmetric point. I can see that this point is just 1 to the right of the axis of symmetry. So let's plot its symmetric point 1 to the left of the axis of symmetry. And then I can go ahead and draw my parabola right through these points here. A good way to check this is I can use my graphing calculator. So let's plug this into our graphing calculator and let's see if it matches. So I'm going to go to y equals. Let's plug in our equation, 2x squared plus 4x plus 1. I can do second table, and I can see the points that I picked out here. My vertex is the point negative 1, negative 1. I can see my y-intercept is here at 0, 1. And then I can see the symmetric point is here, negative 2, 1. I can also hit graph and see that my graph on my calculator matches with the graph that I drew. Okay, lastly, let's state the domain and the range of this graph. I'm going to do that on the piece of paper over here. Our domain is always going to be all real numbers. So I'm just going to draw the symbol for all real numbers. You can also write it out in words, all real numbers. Next, let's do the range of our graph. Our range is only talking about the y. Let's look at the y of the vertex and look at how the arrows are pointing. So my y is greater than or equal to, because the arrows are pointing up, so greater than or equal to, and then the y of the vertex here is negative 1. So y is greater than or equal to negative 1. Let's do one more of these just so to make sure we get the hang of it. We're going to do number 6, monitoring progress 6 from the textbook. So let me write down the equation. Here it is, p of x equals negative 5x squared minus 10x minus 2. Let's start off the same exact way here. We're going to find the axis of symmetry and the vertex. So x equals the opposite of b over 2a. Let's label our a, b, and c. Here a is -5, our b is -10, and our c is -2. Let's plug it in. This is going to be the opposite of -10 over 2 times -5. The opposite of -10 is +10 over 2 times -5. That's -10. Let's divide these and we get -1. And that's just a coincidence that we got the same thing that we did over here, but that's okay. Let's plug this into our equation. Let's find out what it equals. -5 times -1 squared minus 10 times -1 minus 2. Order of operations, -1 squared is 1 times -5 is 5. -10 times -1 is +10, and then minus 2. This becomes 5 minus 2, which is 3. And now I can write my vertex. My vertex is the ordered pair, -1, 3. Next, I need to find the y-intercept. The y-intercept is just the c from my equation, and the c from the equation up here, we already said is -2. Now I'm ready to graph. So I'm going to go over to my graph paper. Let's do it this way. And let me draw my coordinate plane on here. Okay, let's start with the axis of symmetry. So again, it's x equals -1. I found that over here on my paper, x equals -1. Let's go ahead and draw that in. So I'm going to go to my x-axis at -1, and I'm going to draw a vertical dotted line right through -1. And there is my axis of symmetry. Let's plot our vertex. The vertex is -1, 3. So I'm going to go -1 up 3. There's our vertex. Next up is our y-intercept. Our y-intercept is at -2. So I'm going to go to -2 on the y-axis and plot that point. Now this point has a symmetric point across the axis of symmetry. Because it's 1 to the right, now I'm going to put the point 1 to the left of the axis of symmetry. And now these are the 3 points that I need to draw my parabola. And notice how this parabola looks different. It's pointing down, and that's because our a is negative. And look at how narrow it is, and that's because our a is 5. So this definitely matches up. I can even go ahead and go into my graphing calculator and just double check that I got it right. Let's type in the equation. -5x squared minus 10x minus 2. Second table. Check my vertex. My vertex I got is the point -1, 3. And then my y-intercept is 0, -2. And then this point over here I got is -2, -2. So I got these points correct. Let's hit graph. Let's see if it matches up. And yep, it looks exactly the same as it does on my paper. Last step is let's state the domain and the range. Our domain is always going to be all real numbers for every graph in a quadratic function because it can be any x. Let's do our range now. For our range, we're going to look at the y's. Look at how the arrows are pointing down on this graph. That means that the y's are going to be less than or equal to, and now we're going to use the y of the vertex. So the y coordinate of this vertex right here is 3. So our range is y is less than or equal to 3.